Welcome everybody, welcome to this meetup. In this meetup we will talk with Oren. We will discuss about Azure Cosmos DB in your application. We will discuss about data model and the proper design and the best practice for building application using Cosmos DB. Oren is the CEO of RavenDB. RavenDB is a NoSQL distributed database. And now I share the screen of Oren that can start this meetup. Welcome, Oren.
Hi, thank you for having me. Can you see my screen?
Sure.
Okay. Okay. So let's start by giving you some introduction about who I am. And my name is Oren. I build a NoSQL document database for a living. So databases are my passion and what I make my living in for the past 17, 18 years or so. One of the things that my company has been doing is work with not just building RavenDB, but also work on ORM profilers, tools that sit between your applications and the database and analyze the traffic. What we did was we also built a profiler for Cosmos DB. So this is where we got a lot of the information that I'm going to discuss in this presentation. And the Cosmos DB profiler basically sits between you and Cosmos DB and figure out what you're doing and give you some suggestions about how you can improve. Now, let's talk about what is Azure Cosmos DB in the first place. This is the marketing line, proprietary, globally distributed, multimodal database, blah, blah, blah. Basically, it's a database that runs on Azure. And the nice thing about it that it can run in global scale. You can put petabyte amount of information into that, and you can query that in all sorts of interesting ways. You can query it using SQL, using graph operation as a MongoDB API, all sorts of other stuff. And when you start looking at it this manner, it's a really attractive offering. It means that, okay, I have something here that you can use for everything because it has API for everything. But now when we're talking about how to use Cosmos DB properly, we have to understand some key concepts. So the data model is around documents and containers. I have a sample database here, and you can see that this is Cosmos DB. And there is basically Cosmos DB is locking you into Azure. There is a local instance that you can run, but in general, you run that in Azure. And you have a container, you have a database, the database contains containers, and the containers contain documents. Documents look like that, as fairly simple JSON. You can also write queries, and somewhere here I have a, no, I forgot where the query is. There we go, query. So I just want a new query. There we go. So now I can run this query, find some results. I can also do stuff like this. And he does not like it. Maybe C dot. There we go. Now, if you look here, you're going to see something really interesting. This query costs 2.83 RUs. We discuss what RU resource unit are in just a second. But notice that in this case, we have the ID, we have this. We can also define a lot of other things that are currently irrelevant. The most important thing is that the data model for Cosmos DB are documents. Documents are relatively small. The format is JSON. You can use arbitrary complex data, but documents are small and they are independent. if I would try to do something like this, if you go to the queries and say, it doesn't work this way. You can't do a count, you can't do, you can do some queries, but a lot of the things that you can do are heavily limited. So even though it's using the SQL-like language, the limitations are very high. So the typical model is that you have small independent documents. You're limited the number of queries that you have, the type of queries you have to really design for that explicitly. And why is that? Why do I have to design specifically? Why do I have those limits? And the answer goes back to here, to the underlying concept that you have here. Cosmos DB is meant for a large dataset, for globally distributed datasets. If you don't have very large datasets, then you're paying a bunch of money and time and effort for almost no reason. Because a lot of the limitations that you have on Cosmos are all about managing large amount of data. And it doesn't necessarily have to be at the petabyte scale, but if you have, 50 million records, something like that, put it somewhere else. You don't really care about that. That's nonsense. If you have 500 million records, put it somewhere else. It's cheaper, easier. But if you have 500 billion records, then you want to consider using Cosmos DB, because now it makes sense. And now a lot of the limitations are also there for a reason. And the example of the limitation on the queries, I can't do a count. Well, if you do a count, then I have to scan the entire database in order to find that. Try to imagine that the data is actually spread across 100 different servers. A count requires me to go to all of them. But a query does not, because I'm only going to give you the first few results. So that's much cheaper to operate. The major reason is that now that I have it in Cosmos, I can scale it as much as I want. And again, I cannot emphasize this enough. If you have smaller data set, move it somewhere else, it would be easier all around. Now, let's talk about pricing. And it's funny that I'm starting to talk about pricing from the very first step. Why am I doing that? And the reason is that one of the primary architectural properties of Cosmos DB is that pricing and design are intrinsically linked. What Microsoft has done, which I think is very smart, they said something very simple. I'm going to expose to you the actual cost of doing things. If you ask me to do something expensive, I'm going to make it more expensive. As simple as that. And the unit of measure that they use is request units. And each request unit costs some money. Not actually true. We discuss exactly how it goes in a second. But basically, writing a document costs about 4 RUs. Querying a document, Christine, has its own cost. What do you want now? C.ID. There we go. So this is the cost of this query. If you run it multiple times, if you run it concurrently, then it adds up. Now, RU is 1 per kilobyte, which sounds like, well, this is good. This is easy. So how come this document, which is 94 bytes total, or let's do this and see how much bytes do we get? 332. How come this costs this much? And the answer is that you're charged for all of the reads that you're doing, not just the reads on the document, but also the reads on the index that you have to find the document, those sort of things. Now, consider this scenario. You have 50 users, each of them is using a 10 kilobyte document. Maybe it's a social media post, maybe something like that. And they read them only for every 5 seconds. Here, the cost that you will have for that. A 10 requests per second, 50 a month, 5,000 a month, 50,000 a month. Now, Cosmos actually have multiple billing models. You can reserve capacity, you can charge, you can pay by how much, how many are used in total. I'm not going into that. The important thing to understand is that in many cases, when you design Cosmos DB, one of your primary consideration is going to be around the cost model. How can I avoid paying additional costs? And it's very easy to have cost overruns. The other thing to understand is that when we're talking about Cosmos DB, it's going to run on multiple servers. So what does it mean that it's going to run on multiple servers? Why do I care? Well, because it's running on multiple servers, you have to think about how the data is actually spread out. Because again, it impacts what you can do. So for example, you have logical and physical partitions. In this case, this is one server, this is another server. Each one of them is actually however many replicas you actually need for the data safety that you want. But in general, this is the logical limit. A single partition can take up to 20 GB and have a maximum of 10K RUs. So far, so good. The physical, this is how you would typically talk about this. This is what actually happened behind the scene. This is where you have an actual instance, an actual server serving those requests, and the replicas that it have, and all sorts of stuff like that. Now, let's say that I'm dividing my data. My partition key is done on the city. This means that all of the orders from London will go to the same location. All of the orders from Paris would go to another location. Now, it may happen to be that both of them are in the same server, but Cosmos is managing that for you. So if your data grows and we need to move things around, then it will do that. Now, it does mean that you have to take into account, okay, what's the impact of this? What is actually going to happen here? What happens if I have more than 20 GB of orders to London? The answer that you're going to start to get failures. You can't, a partition is unbreakable. There are probably ways around that you don't want to get. But the partition is effectively unbreakable, and now you have to consider how to work with that, how to manage that. And if you go beyond the 20 GB, that partition is effectively dead to all intents and purposes. So when you select the partitioning key of your system, this is something that is really important. You can't select something that is too common. And in many cases, you want to select something that would spread the data in an even fashion. Now, what does it mean, spread the data in even fashion? A really good scenario for working is that your ID or your partition key is going to be random, like a GUID. Now, the question here, why do I want it to be a GUID? Why do I care about this being random? Because if this is random, I get the perfect distribution of data. Each one of my partition, each one of the physical partition is going to be roughly the same size, and I can effectively partition in the each partition infinitely. I don't really care about that. However, there is an issue that we have to take into account. What happens when I choose a partition that is roughly random? For example, I'm using the user ID as my partition key, and all of the data that belong to the same user is the same partition. That leads to an interesting observation. When a user starts acting, I'm logging into the system, I'm starting to do things, what's going to happen? Let's do some math. First thing that I need to do, let's do some math here, that's easier. I'm going to read the recent post for this user, assuming I'm talking about the social media. And I'm going to take 50 of them, and they are 2 kilobytes each. So here is 100 RUs that I'm using to make a single query for this user. All of them are in the same partition. Now, consider what happens if I have other things that I need to make. I also need to show the direct messages, most recent direct messages. So that's another 100 RUs, etc., etc., etc. And if a lot of the work is inherently based on the user ID, which is in the same partition, all of that is going to go to the same location, to the same partition, and I might hit the 10K RU limit. Which sounds funny that I'm starting to talk about, okay, I have this massively parallel distributed database meant for petabyte scales, but 10, 15 queries when I'm rendering the homepage for a user can take it down. But that's how it works. We have to understand where the queries are going to. And you know, the reason that I started by saying that you have to design for Cosmos to be explicitly is exactly this. Because there are cost considerations, there are architectural considerations that are really important. And they are important because if you don't do them, things will work. That's the worst part. Stuff will work and you're going to see everything basically happening as it should. But the problem here is that you want, in some point, the system is just going to start crashing down around you. And that's something that is quite easy to get to and quite hard to dig yourself out of. So let's talk about queries. If you, the query here is very simple and effectively identical to what I have here. What happens if I have a lot of data? How do I do that? Well, if you don't do anything, let's see. One of the things that we can do is here, and I want to say gender, email, and update. So now I update this. Notice that I added a new field here. It does not exist here. Let's see if I can query on that. And I can, and it works. It's great. But I noticed that, again, this is 2.83 RUs. If I had 10 million items here, that would be more expensive. And you can see here that time to look in the index hit rate count, and this works because I don't have actually any real work doing here. And Cosmos gives you some good information that you can look here, and if you use the profile, you can see that on any one of your actual queries. But what happens if I don't have an index? Cosmos would still work, but then it would go and read the entire dataset to give you results. This sounds like a very bad idea, especially because you're paying for each one of those resource units. The good thing here is that you're going to time out on the query. There is a 5-second maximum query execution time. So another thing that we have to take into account is whatever we can give Cosmos hints. Hey, I know that this can only be in a particular partition. Don't bother going and querying all of them. And that can be a huge help. Now, let's say that I'm going to query like this. I have no results. Why don't I have any results? Because the query is case sensitive. So I'm going to fix the query. Now I can do this, and I find the results. And I think that I'm sorry, I don't have enough information here to actually show you the actual issue, but this one cannot use an index because this is on upper and we didn't index the upper result. So now we're doing, again, a table scan. And for small data sets, this can be quite expensive, something that you have to be absolutely aware of. Now, let's talk about indexing and something really, really interesting that we have to understand. By default, Cosmos is going to index all of your properties, all of them. Now, that has a very nice result. That means that you can query on any one of those items, on any one of those fields. You don't have to pre-plan everything. But this has a major issue as well, because it means that it costs you RUs. It costs you when you save the document. And in fact, the bigger the document, the more expensive it is to save it. The more fields you have, the more, let's see if I have it here. Not interesting. It doesn't show the RUs here, but the idea here is that the more fields you have, the more expensive this become. And again, you end up paying for that. Try to imagine that you have a complex order document. You have line items, you have products, you have discounts, payments, so much other stuff. And you throw that into Cosmos. And Cosmos is going to index each one of those fields and cost you quite a lot. In terms of the actual indexing, you have hash indexes, which give you exist does not exist, or range indexes, which are quite useful for basically range queries. But in most cases, what you would do, you would say, oh no, I don't want to index everything. That's too expensive. I want to define indexing policies. What are the paths that I'm going to index? I want to index just first name. That's just how that is how I'm going to query stuff. Now, but however, at that point, and let me show you how you can do that. We create a new container. Item and K400 container ID. This is what is the username. What is the key that I can partition based on that? This is email. And I have a whole bunch of other stuff. Somewhere around here I have the ability to define what are my what fields do I want to index. Oh, sorry, this is the thing I forgot. I didn't notice that. So I have to say off, and then I can select which fields do I want to index. No index, no query. Cosmos also supports spatial indexes and composite indexes. Spatial indexes are to find things by geographical location. That's fairly relevant. But composite indexes are interesting. They are not used for queries. They're used only to allow you to do order by. So if you have, and by the way, that's another issue. Order by is expensive because you have to sort the data. You can use composite indexes to help here, but again, you have to know upfront what you want to do. if you will notice, this is something that they keep repeating. You can make great things happen with Cosmos, but it requires you to know upfront what you're doing and how to best utilize that. Now, let's talk about some of the limitations that we have, which are important because, again, they're going to impact your system. The document size is 2 megabytes, which is an interesting choice because on one hand, it's big enough for you to, oh, I don't need to think about it. And it's small enough that you can actually hit it very, very quickly. Think about an order. And again, I'm using order because it's a very simple scenario. An order that has a lot of items. And any B2B order may actually have a lot of those items. And on each of those, you have data such as how do you pay, what are the benefits for this, whatever this is participating in these sales, promotion, those sort of things. You hit 2 megabytes of JSON, and Cosmos DB refused to operate anymore. The other thing that we have to take into account is that the response size from Cosmos is 4 megabytes. And why does it matter? It matters because it means that if you have large documents with a few hundred kilobytes each, then you can't get a big page of them. You have to take into account what is the actual size that you're going to do. Finally, the max request duration is 5 milliseconds. Afterward, you're getting a timeout, which is something that you probably want because if you messed up and you now have a very expensive operation, you don't want it to start churning through all of our use and giving you a huge bill at the end of the month. Transactions. Transactions can happen in one of two ways. You can write a stored procedure, or you can send a bunch of operations. Now, here is the issue. A transaction can only happen within a single partition. So if I want to move money from Joe to Jane, they have, and I want to do that in a transactional manner. And this is the prototypical transaction. This is the example that I use. I want to withdraw money from Joe, give it to Jane. And I want to make sure that this happen with either this completely successful or never happened. And this cannot be done unless both Joe and Jane are in the same partition. Now let's say that I'm partitioning on city, on bank account ID or something like that. The chance that you're going to end up in the same partition is effectively none. So you have to think very carefully about how you can use transactions, whatever you can use transactions. Because the other side of making things single partition is that the partition has a certain limit. Transactions are also limited in duration and size. So if I want to send you a bunch of documents and they exceed 2 megabytes, you cannot do that in a single partition. Now, let's talk about something interesting. A partition has a limit of 10K. So let's say that we are running with 2 partitions. And each one of them, and you're running with 18,000 RUs per second. This is this model right here. You're happy. You see 9,000 RUs here, you see 9,000 RUs here, but you're starting to see that you're going to hit the limits. So then you do something fairly natural. You're going to say, okay, let's increase the number of RUs that I'm getting. And you increase that to 21,000. But the partition has a maximum of 10K. 10K RUs. So now you end up in this model. Now, if you have perfect distribution of a float, it doesn't matter. But if a lot of your queries happened here, and now they're happening here, That sucks because previously you have 9,000 RUs to handle that. Now we have 4,500, which is a big difference. Now, just to give you some indication of why this is a problem, let's talk about the impact of just a few queries on the system. Let's say that I have a query that takes 50 RUs. And as we saw, 50 RUs is not really that much. Give me 50 documents, each one of them is 1 kilobyte. Pretty standard thing to ask. And you do that across 100 requests a second. That's 5,000 RUs. Just for that particular page. So you have to take into account how this works, whatever you want to apply caching, whatever you want to apply something else. And the reason this matters is because you're going to get this 4 to 9 too many request error. In fact, the Cosmos DB SDK contain automatic retry specifically to address that. Because you will start getting your request rejected and need to handle that. And in some cases, the retry after some time would help. But this has its own issues. Because now suddenly, based on effectively random details, you're going to start hitting much higher latencies. So we have to very carefully consider how we're going to make that happen. Now, here are some costs, just to give you some of the ideas about what's involved. There are two ways that you can manage the cost in Cosmos. One of them is by using something called provisioned model, and the other one is with the service model. With the provision model, you specify what is the maximum number of concurrent RUs that you're going to need. And this is roughly the cost. So if I'm going to need 5,000 RUs, by the way, at any point in the month, if I need 5,000 RUs, so divide by 100 times 5.84, that's roughly what I would pay. Notice that in this model, what I'm paying for is the maximum capacity over the entire month. So let's assume that my steady state is 5,000 queries, 5,000 RUs, which is far less than 5,000 queries. Now I'm saying RUs, but whenever I'm saying RUs, I'm talking about request units per second. It's important to understand that. Now let's say that at 9 a.m. Monday morning, everyone logs in. And after the weekend, the cache is empty, so I have to load everything. Which may mean that I have to deal with 50,000 RUs. Just on, Monday morning to handle that. And again, they charge 5.84, and now you're close to 3,000. Another way to handle that is to go with the auto scale model, which basically say, okay, I will manage that. You don't have to pay for the maximum capacity that you have. We will handle that, but the downside of that is that you're going to be charged close to double what you're used to, which is not fun. Now, the benefit here is that Azure will manage the provisioning automatically. There is some issues here with the speed in which it goes up and down, but not too badly. But still, even in order to handle the 50,000 every Monday morning, you have to effectively pay double the cost. Finally, and most interestingly, you have the service model. And in the service model, and when you create a, what is that? when you create a new thing here, you can select what would be your capacity mode, and that applies for the entire Cosmos DB account. And the basic idea, where is that? You can see some of those. Where is the? There we go. Here's the service, and what you're paying for is, where do I see that? There we go. Okay, notice this. You get billed for the request units. Now, why am I emphasizing that? Because here you're getting request unit per second. Here you're getting just request units. Why does it matter? Let's imagine that you have 50 request units per second on a constant basis. Let's say, so this is the number of calls, this is the number of requests units you will make. Seems relatively large, but okay. And that fits comfortably within the 100 RUs that you're looking at here. Perfect. In here, that would mean that you're paying for each one of those RUs. Now you're paying almost nothing, $36 versus the 23 that you would pay here. But it's important to understand what the difference is. The good thing about this is that it frees you from a lot of the complexity around managing the maximum capacity of the system. The downside is that you're charged per RU that you send, even if you are now on an idle period. Now, there is also the storage cost, but honestly speaking, let's say that I have 5 terabytes of disk space. So it costs me nothing really that important. And notice that even with 5 terabytes, this would be nothing compared to this. Now, let's look at some examples. You can see here, this is the code that you would write. And this is how, this is the query that would show when this is what you would see in the profiler. Notice that this is a much more interesting query. Now saying, hey, give me the ID on the query, give me the item by ID, and I want you to know that it's in this partition. So it doesn't, so Cosmos doesn't need to go and try to find it in all of the partition. It can go directly to one partition, and that can save you an amount of effort and save you the RUs, therefore save you money. Now, you might notice that I keep saying cost, cost, cost. This is because this is the complexity. And in some cases, you will see that Cosmos DB is the single largest charge you will have by far. So you have to model carefully, you have to think about what you're doing. Small documents, try to avoid queries, try to think upfront what queries you have, what sort of indexes you have. You want to try to read by the specific document ID on the particular partition that you have. This is the ideal query that you want to have, not stuff like this. This do effectively the same thing, query by ID, but this has to query all of the partition. This goes to a particular partition. Now, if you don't do that, then you get to here. If you do that, then probably it will be less, but still expensive. That's why I'm recommending that if you have something that isn't absolutely required, then you would use any other setup because it's probably going to be cheaper and easier to work with. Another thing to take into account is that the indexing policies and those sort of things are stuff that are more or less defined in stone. If I'm going to go here and this, So in here, somewhere around here, I have the ability to look at what my indexing structure is. Maybe here. I'm not saying that, but please don't try to steal my data. I'm not seeing that. I remember something about being able to modify the indexes, modify the index, but in most cases, even if you can do that, that requires you to read and write all of the indexes again, all of the documents again, which is hugely expensive. And given that I can't find it easily, I think that it might not actually be possible. I'm sorry, I had something in my head. I'm not sure that I'm giving you the accurate information. But in general, once you set up the indexing policy, it's set in stone. Even if you have this feature, the RU cost for doing that is horrendous on large data sets. Now, let's talk about some other aspects. Backups is something that you kind of need to have. My data is important. But Cosmos gives you 2 backups. You can set up once every hour or up to once every 24 hours, and they can be returned for some amount of time. But you have 2 of them. So I'm not sure what the retention policy means in this case. Now, how about if you want to restore from backup? And the answer is that you call support and ask them to do that, which is a thing, a big thing. Because Cosmos is used for large databases, it means that, oh, I now need to restore a 5 terabyte database. Effectively means that I'm going to be down for potentially hours, days, something like that. If you need, I need to restore a backup because I need to look at how my data was 2 weeks ago because I might have a cyber attack, or I might need to do that because of legal reasons, well, that's going to take some time and that's going to be quite complex operations. In terms of operations, you're also going to need to watch carefully what's going on inside Cosmos, and you have quite a lot of metrics that show you what's going on. Finally, I really encourage you to look at careful design of how you approach the Cosmos DB usage. If possible, try to limit it to the stuff where we actually need that level of scale. I'm not touching on some of the features such as global availability, the consistency of the system, stuff like that. In many cases, even when you can use that, the cost of that is significant to the point where you say, oh, I don't want to do that. And one thing that you should not ever do is try to migrate an existing system as is to Cosmos. Because the cost model are so different, you're going to hit a lot of complexities. The cost is an ongoing concern, and you will find yourself watching the billing dashboard to see whatever things are happening properly or not. And there are a lot of easy way that your cost can skyrocket. For example, this versus this doesn't seem like a lot, but that can have a significant impact on the number of RUs that you have. You can see it here. Here I have 2.83 RUs. This is a query. This is pretty much the baseline cost of a query. This is 1 RU. Doesn't seem like much until you realize that if you're using the serverless model, then this is going to cost you almost 3 times as cheaply. And it adds up. Sometimes it adds up quite a lot. Now try to imagine that every time that I hit F5 on the browser, you hear a ding from your credit card. Because, oh, ding, this now costs us 5 cents. Ding, this costs us 16 cents. Those sorts of things. The downside of planning and carefully consider every use case is what happens when you have changes. The reason that Cosmos by default index all fields is that you're going to have new queries in the future. So you have to take that into account. Whatever, okay, do I want to limit the number of fields that I want to index? Do I want to work with that in some manner, stuff like that? Something that is an interesting approach to dealing with that is to do something like this. You tell Cosmos when you build this, I want to do this. Basically stuff like this. And I want you to index this. And now for some documents, you can have dynamic indexing, so to speak, because city, all sort of stuff like this. And this is a pretty cool trick to allow you to add additional fields to be indexed on the fly, because you're indexing this as a dynamic data, as a dynamic array. And look at the polyglot strategy. Something that is important, you can set up change feeds from Cosmos. So whenever a write happens to Cosmos, you will get notified. And you can put that in as part of your serverless strategy. You write into Cosmos, there is a serverless function that is going to run and process the change, something like that. One thing to note here is that it doesn't support deletes. So it's something that you have to take into account. And now is the time for questions. I would be very happy to answer any and all questions that you have. And I actually don't know how to do questions. Yes.
Hi, Oren.
Yes.
Oh. Okay, 1 second. I'll take. I have a couple of questions, but before question, 1 second. I present you the next meetup. Is not the next meetup because this is the actual meetup. This machine learning models continuous deployment on Azure using DevOps, and I ask you to register for selfie lottery because this day we give away a license of JetBrains. Now I share the link of of the selfie lottery, and I show you and I ask you some question, a couple of questions. Is possible or useful partition by spatial field for you?
Depending on how you want to define spatial in this case. So the typical way, so a spatial field may be a polygon, maybe the shape of a region, something like that. At that point, you have to, let's say that I'm talking about the shape of a city. And the shape of the city looks something like this.
Okay, sorry, 1 second, I share your desktop. Oops. Okay.
Yeah. Are you seeing the screen now?
Yep. I forgot to share the link of selfie lottery, but I'll share it later. Okay, wonderful.
Okay.
My
now,
fault.
Look at here. You have two regions, which are some complex shapes. You can say, okay, I have point here, I have a point here, I have a point here. It looks sort of like a fish. Now it's a funny fish. Anyway, so this one is expected to be in a different partition. Now, if you want to partition by spatial, then the question is what you should be doing here. Everything that matches this shape, but my spatial is usually a particular location, here, here, here. So that probably won't do that. The other thing that you can do is to say, okay, let's put that as as the city, the location, something like that. Next, you have another option, and that option is to use something called geohash. And basically, you divide the world into squares, and each squares into further square or something like that. And every long lat value that you have can be specified as a particular string. And this looks something like this.
Wow.
And now you can say, okay, I want to be able to specify partitioning on this, on that. Now you can partition based on where you are on the square. However, that gives you a different problem. And that problem is that now I have someone who is here and someone who is here. And they are very near one another, but they are on different grids. So a lot of that depends on exactly what you're doing and how you're doing that. In general, I would say that spatial partitioning is strange, and I would like to hear more about what is the scenario in question.
Okay. Can I continue with the other question?
Yes, absolutely.
Okay.
So there is one for you. Will the presentation be released after the presentation?
Okay.
I'm assuming that the answer is yes. Okay. What piece of software did you use to show query performance?
Francesco asked, what is your software for your performance?
This is this. And the software that I typically use was something that was written by us. And you can go to hibernate-users.com, and here you will find products. And here you find the Cosmos DB profile, and you can download that, and that would give you the information about exactly what's going on, including, by the way, and that's important, you can see here that here is the query, here is the number of RUs that you used, but now you get also alerts. Oh, here is a query and you can use a partition key to it. Here are the different levels, you don't care typically about that, but somewhere around here, you have a lot more. Here is how much this cost, why did it cost, all sort of diagnostic you can find about what's going on, or this index, this query can be done better, a whole bunch of other stuff that can be really interesting. Most important, I think this gives you the ability to tie a particular query, which may be quite expensive, to the exact line of code that generated that. Now,
the next question is, Dave, would you use for event sourcing?
Very unlikely, and I will explain why. Because in event sourcing, in many cases, the fourth step that you have is write the event, and then you want to do some aggregation on past events based on the new information. And aggregation in Cosmos is awkward. It's very hard to do. You have to maintain a lot of that yourself, or you have to issue quite expensive queries. The typical way I would model event sourcing in Cosmos would be, okay, I write and then I say, give me the previous state of the event that belonged to a particular stream. And then I try to merge them. But in many cases, I also have to access the actual event stream. And that means that on every write, I have to do, oh, give me the last events. I have to deal with, oh, I cannot easily do it in a transaction. And in most cases, the event belongs to a particular a stream of events. So events of a user, events of a particular order, something like that. And most of them would tend to belong to the same partition. That's the different way to do that. What happens if I have a long running stream? For example, I may have let's say that I'm tracking stocks and events is buy or sell on particular stock. If that stock is very active, I may hit the partition size limit. And what do I do then? So this is something that you have to really think about. Okay.
Wow. Patrizio say if does exist a site for have a template with a significant amount of data for testing.
Yeah. So the question here is, what do you define as significant? And that is actually a really interesting question. Kaggle is giving you all sorts of interesting data sets, and some of them can be quite big. There is the billion taxi dataset, and that is a lot of taxi trips in New York City. That apparently they publish all of that. In Kaggle, one of the things that may be fun is, let's see, big. And okay, so you have all sorts of sometimes very silly things, but a good data set to work with is the movies data set. And the movie data set gives you, what is that? Some of movie dialogue, but there was one, okay, here it is. So now I have extensive movies. Now, here is the deal. This is not a big data set. When you start talking about big data set, especially if you want to try it out with Cosmos, then you want then most of the data sets that you have are relatively boring. Boring as in, okay, let me show you the emission signature for the past 50 years, stuff like that. Oh, this one is a good one. Used to be good. And Google published a few of those. But then again, you're going to see, okay, fertility rate over time, or here statistics and stuff like that. Not really that just interesting. But the public data sets are really interesting. The open flights is not too big, but also this gives you realistic data sets over a long period of time. In some cases, you can download all of that. In other cases, you have to torrent that and a bunch of other stuff. But a lot of that depends on what you're doing, what you want to try. Take into account, if you want to deal with large data sets, then you have to take into account the price.
Okay.
It's very easy to burn a lot of money that way.
Wow, the best way if that you read the Daniele question, because contain also some line of code.
Okay. If you take a query like the following, the data contain only partition Caribbean, and the partition is wrong. So I'm saying issue a query. So the scenario is basically this, but instead of passing the right partition, I'm sending it to the wrong partition. And what will happen is we'll go to the wrong partition, it will find no results and give you not here. Okay. And he's saying that this can happen when you set a random partition key to get more partition as you can. And that's why you tend to not just generate them randomly. The whole idea is that you want to have a random partition key, but some meaning to that. And that might be a random user ID, and all of the documents belong to a user having the same partition key. That might mean something like finding not necessarily the user, but something smaller. For example, I might say, okay, I want to have a user on orders. And orders may actually be composed of quite a lot of work. I have the order documents, I have the shipping, I have the tax, invoice, all of that. So the order ID would be the partition key for all of the related items. And that way I know that, oh, I'm querying something related to this order. I know that I can use the order ID as the partition key. Notice that the randomness of the value doesn't matter as long as the values don't repeat. So if I have 1, 2, 3, 4, 5, 6, it's perfect. As long as I'm not saying, oh, I'm using the city, the something that is repeatable and can cause wide variances in the distribution of values.
Okay, the last question is, so what will be a partition strategy? One partition per aggregate?
You don't actually control the partition. You control when the partition is, because all of the items with the same partition key are going to end up in the same partition. So if I have a DOS partition AAA must be in the same partition. AAB may be in the same partition or not. This is something that you don't control, you don't care. At some point, if this is too large, this is the scenario that you have. At some point, Composite says, oh, this is too large, I'm going to split it up. It cannot split this up. So this is limited to 20 gigabytes. So if you use such as stuff like that, it is able to partition them as it wants, and you don't have too many items in the same partition.